Okay, whew, here we go.
What do you mean we? I have to do this thing.
Yeah, new products. Okay.
I'm doing it.
First up, Bluetooth Low Energy. You released it. It's here.
We did release it.
This
was like years ago. This was 3 weeks ago. We released. This is a K-Town joint. This is the NRF 8001 from Nordic, and we really like this fairly low cost and pretty easy to use SPI Bluetooth core chip. This is a chip that basically handles the Bluetooth layer for talking to, a phone, a device, basically the client version of Bluetooth. We made a breakout for it. You can see this great breakout with very small components that we use that gigantic pick and place to place, and has level shifting as well. So this does all the Bluetooth Low Energy stuff for you, and we even have
Let's go to the live demo of something we recorded. Yeah.
Hey everybody, it's me, Lady Ada, and I'm here at the ever-busy Adafruit factory where we are currently manufacturing, kitting, and shipping your orders. But I'm here today to talk about our new Bluetooth Low Energy module. This is the NRF 8001 Breakout that we just released. I'm going to be talking about this module as well as the iOS app that comes with it. Our Bluetooth Low Energy Breakout features the NRF 8001, a great Bluetooth core by Nordic. We also add supportive technology around it, a level shifter, onboard antenna, and a breadboard breakout for connecting to the SPI bus. Check out the Learn tutorial to follow along and wire up this demo board. We have our NRF 8001 Bluetooth module connected up to an Arduino, a large red LED to demonstrate digital outputs, an RGB LED with a diffuser to demonstrate PWM outputs, a small tactile button for digital inputs, and a potentiometer so we can show off analog inputs. Once you've wired up your Arduino with all the LEDs, buttons, and potentiometers you like, download the Bluefruit LE Connect app from the App Store and tap Pin I/O to begin the Fermata demo. Let's begin by controlling Pin 8, which we have wired up to a red LED. Click on the Pin 8 bar, set it to be an output. Then you can have the pin go high or low to turn the LED on and off. Now we can try experimenting with the PWM outputs on pins 3, 5, and 6. Select pin 3, 5, or 6 and choose PWM mode. Then you can move the slider to set the PWM mode between 0 and 255. We can also read button inputs. I have a button connected to pin 4. By default, the pin is already set up as an input. Wiring up a button, whenever I press it, the app recognizes the button press and lets me know if the pin is high or low. Finally, let's read an analog input connected to pin A5. Select analog mode, and I'm twisting this potentiometer connected to that pin to make the value change. As you can see, this is the easiest way to add Bluetooth Low Energy to your Arduino or other microcontroller project. So check out the NRF 8001 in the Adafruit shop, as well as Bluefruit LE Connect in the App Store. Okay, so as you can see, we have a great iOS demo for Bluetooth Low Energy, and all that code is open source as well. It's on our GitHub repository. So if you'd like to do some Bluetooth Low Energy hacking, and especially if your project is very basic, like you just want to send data back and forth between a phone or tablet and an Arduino, we have example code for that already that does the UART data passing back and forth. So we'll have some more projects with that, but it's super popular. And this is like 20 bucks. It's a super cheap way to get into Bluetooth Low Energy, and it works really, really well.
Okay.
Nice work, Nordic.
Here's another, much like our site, a year in the making. This is the MP3 Shield for Arduino.
Yeah, this is our
the big one.
Music Maker Shield. It does, I hate to call it MP3 because it does so much more than MP3. It can do wave, FLAC, UGG, Vorbis, AAC. It also has a MIDI synth built into it. We have a VS1053, that's the name of the chip that does all the work. We have it on a Breakout already, and people were like, well, we want an easier way to connect it up to an Arduino. And so I basically took that Breakout and I expanded it out into a Shield, and I made 2 versions. Now this version, if you look in the bottom corner all the way there, there's another little chip, and it says Stereo Speak 48 ohm BTL. So on the amplifier version of this board, I also include a 3-watt Class D amplifier, 3 watt per speaker, so that basically you just attach speakers of like, you know, any size about this big or smaller, and you're ready to go, as long as you can handle up to 3 watts of power. And you can power it from the 9-volt jack. You can also use headphone if you don't want to use speakers. The headphone is line out safe, so you can see those big capacitors next to the headphone jack. That means that it's safe to plug this into powered speakers, a stereo system, or headphones. A lot of like, you know, low-cost MP3 shields or that use this kind of chip leave those capacitors off, and if you plug it into your stereo, you'll actually blow up the chip, which is kind of sucky. And it reads music off of a microSD card, so there's a socket there. Just put in any FAT16, FAT32 formatted microSD card in there, and just drag the MP3 files or WAV files or OGG files on there, and then use our Arduino library. It's really easy. And this shield also works with Leonardo or Mega. Tested, works well, and it'll probably work with Duo as well, or Yun, although the Yun I think has the capability of doing MP3 decoding on board. So it's a really like flexible all-around music player. It's a little more powerful than the Wave Shield. It's also fully assembled pretty much. Just put headers on it. I can show it off real fast if you want me to just demo it.
Yeah, let's do a quick demo.
Okay. So I've got here, this is the version with the speakers. So you attach terminal blocks, and these are the speakers, and this is that SD card that I'm just going to insert, and I'm going to hit play, and you can hear it's playing out of the speakers. You can also use the bone conduction, not speakers, but the transducers that we have. I'm going to depower this so we don't get hit with the YouTube copyright music thing. So here's the chip. There's these jumpers for using with a Mega or Leonardo. This version has the amplifier, and then this version, basically the same PCB, but I just don't solder the amplifier chip on there, and it's $5 less, which is nice. If you don't mind just using either headphones or stereo, just plug in a standard 3.5mm plug in there, and you got music. So it's, you know, higher quality than the Wave Shield. You can, you know, do a lot of stuff. You can do like bass and treble manipulation. Volume control is also handled on the chip. I think it'll be pretty popular. There's also a MIDI synth. We have a tutorial about that for the Breakout, and we'll have a full tutorial for the Shield soon. We were busy bringing up that new site.
Next,
so didn't finish that.
It's time to get your retro gaming on. That's right. It is the Cupcade. So this is kind of what I would like to say is another classic Adafruit project.
Not only is it classic, it's a Phil B project.
And yeah,
it's a Paint Your Dragon project.
This is something that only Phil B could do.
This is something only Phil B could do, and this is actually a project that's been in the works for 4 years now.
Yep.
Originally, I wanted to build this with a Chumby. I always wanted a little micro arcade ever since I was 12 years old, and they had these little Frogger arcade, like little mini ones from like Tiger or whatever. I don't remember who made them, but they were like, they had them at Toys R Us. I really wanted them for my birthday. My parents didn't get them for me for my birthday, and so basically I've had this hole in my heart for like 20 years for this little mini arcade, more than 20 years. So finally, I have one. This is a lovely kit made by Phil B. It uses a Raspberry Pi and our Pi TFT, little joystick and buttons. By the way, I got the joystick and buttons for this project. This is like a long time in the works to get all these parts together. A lovely laser cut case. Couple of components just to, you know, handle the joystick and buttons into the Raspberry Pi, and you've got a lovely little arcade that can play MAME, and we will eventually at some point show even how to play NES classic games on it. I know it works, but I don't have a tutorial for it.
So here's
let's show some photos.
Joust. Here's everything.
Oh yeah, you can have it be horizontal or vertical mode. When you build it, you can choose. So that Joust is horizontal mode, and then if you look at the main photo, it's pack mount is vertical mode. So you pick which one you want to get the best screen.
Okay, and here is a very short video.
Adafruit presents Cupcade, featuring the world-famous Raspberry Pi computer and Adafruit Pi TFT Display. They've joined forces to play classic 1980s arcade games. It's tiny, it's adorable. Take it to the pizza parlor, take it to the park. It's so incredibly cute, you might just throw up.
I still suck at these games.
Not available in stores, batteries not included, some assembly required. Side effects may include leg warmers, Bon Jovi flashbacks, and permanent 5 o'clock shadow.
Okay, but wait, there's more. So we're also working on a sticker set. This is just a preview. This is a mock-up.
That's a mock-up. That's not. So we're working on a sticker set, but we wanted to release. So we have the beta kit. Can I just show it really fast? The kit in the overhead.
We're gonna go to the overhead right now.
Okay, let me see if I can. Can you?
Yeah. What do you want?
Let me see if I can get this to. Okay. Hold on, maybe I'll just hold it as it. Can you brighten it up a little bit?
Yeah, I can do that.
Okay. So we have a little menu system. Whoa. That we wrote in curses. No, not the saturation. Not the contrast.
That was brightness.
No. Yeah, but you changed the contrast.
Nope, didn't change it.
Oh, really? Okay. Weird. Uh oh. Okay. Hopefully that'll be fine. We made a little scrolling. Selector for games. This is hard to see. So it looks through your MAME directory to find what ROMs you have. And then you can select them. And then it basically plays them on the little screen. And oh, that looks really good. And then you can add coins. And then you can play all these fun games, and it has a speaker built in, so it sounds really good. And then to get out, you just press both buttons in the front, and then you can exit back to the main menu. So that allows you to like play a whole bunch of games, because it actually wasn't an easy way to select what game you wanted to play from all the menus were like made for HDMI screens. Yeah. It actually took a long time to get the curses code working, but Philby attacked it with a vengeance. And we have like a list of all the games that it works with. It plays like Frogger, Pac-Man, Kix, Joust, Donkey Kong, all like the most popular like 80s games. It doesn't play like Neo Geo games. The Raspberry Pi is not fast enough to emulate it. And it can't play some of like the later like hardcore Sega games. Gauntlet's kind of like the limit of what it can do. Anything more than that, the Raspberry Pi can't emulate fast enough. The Raspberry Pi's not very fast.
So we have 30 or more things to get through, it seems.
Okay.
I'm just gonna, you could just say next and I'll just blow through these if you want to just go through them fast. Okay,
this is it's just a panel mount RCA extension cable. So, it's for a Raspberry Pi or something in a case. You want to have audio or the video come out. It just allows you to panel mount RCA. It took us a long time to find this. We have panel mount almost everything else. We have even longer Raspberry Pi camera cables. These are tested and work with the Raspberry Pi camera. If you want your camera cable to be 18 inches or 24 inches long, we have those size now.
Okay. And just a quick tour of all the different...
that's the cable being used.
Yeah, that was the cable over there, but all the different... all the different... cable.
Longer. Longest. And then we have to curl it up to take a photo.
Yeah. Okay.
Just swap it out with the camera cable you have now for your Raspberry Pi camera.
You got the Music Maker Shield. You're going to need some speakers. We got speakers.
This is actually for the, these are really big speakers. These will work, but these are 20-watt like car speakers. And we carry these for use with our 20-watt amplifier. I don't know if I even have one of these speakers hanging out here. Yeah, I mean, I can just hold it up, show how big it is because of scale. So this is how big the speaker is. It's like, 4 inches or so. It has this grill that you can remove or keep on, I don't know, depending. They sound pretty good. They're meant to be used in cars, so they're very forgiving, but I would suggest putting them in an enclosure that gives it better resonance, more bass. And
what the heck is this thing?
Anemometer? I actually don't know how to say this word. Anemometer? Okay, so this has a rotating set of cups, and then when the wind blows, it rotates this, and there's a Hall effect sensor inside, or some sort of, actually I don't know exactly because I didn't open it up completely, but it outputs an analog voltage that is linear with wind speed. So if you have a microcontroller with an analog input or some way to read analog voltages, you can measure the wind speed with this up to 32 meters per second, which is pretty windy. So you're probably good to go with this for
here's some nice
quite a
connectors
wide range.
That seem very
nice durable, and you can remove the connectors and then you can mount it. You have those 4 mounting holes at the bottom. This is the demo one we have here. It's a pretty good anemometer. Anemometer.
Okay, here we go.
Wind sensor.
You have 2 different types of keyboards, so we're just going to go through both of them.
We have 3 kinds of keyboards.
Sorry, 3. Geez, you're
3.
right.
We have a wired one. Hey, go back.
Okay. I'm just gonna go
we have a wired keyboard. This one has a USB cable on it. It's our lowest cost keyboard. This is a full-size keyboard, but it's really nice quality. It's a Chiclet keyboard. We've got a couple different types, and we like this one the most. It's nice and heavy. It's not like loose and flimsy. And it's USB connected, so you have to have a USB port. We got this basically for Raspberry Pi and BeagleBone people, but it works with any computer. Yeah. This is the wireless version. Do you notice it has no wire? So it has a USB dongle. It's not Bluetooth. There's a little dongle that you plug into a USB port, but it looks just like a USB keyboard to the computer. It comes with batteries. Also, a very nice quality keyboard. I like the slim design, but it has nice tacky keys. They have a good feel to them. It's easy to use, and it's full size.
Yeah, there are a couple other photos.
There's one showing you plug it into a Raspberry Pi or something and use a remote. And then this one I really like. This is a combo. So this is a mouse, optical mouse and keyboard, both wireless, that use only one USB port. So this is really nice because if you want to use only one USB port for keyboard and mouse, usually you have to like get a hub or something. But this allows you to have 2 wireless devices on one. Again, both really good quality. The mouse is nice and very sensitive, has optical encoder, 2 buttons with the little flexi spring buttons, and even a little wheel in the middle. So these are actually totally fine for day-to-day use as well. They're not just like throwaway keyboards. And using only one USB port is really great if you have a BeagleBone or Raspberry Pi, because there ain't a lot of USB ports on those devices.
Okay, next up.
Piezos. This is a piezo, and this piezo in enclosure. You can mount it to things. It can beep. Yeah. By applying a AC voltage to it from, say, Arduino or something with a tone library, or can be used as a vibration or knock sensor, which is another use for them, because it converts voltage to vibration and like back and forth. Piezos are kind of neat that way. So if you knock it, it'll have a little voltage spike. So you can use it as both a sensor and an output. And this one is fairly large and has these mounting tabs, so it's really good for attaching to stuff.
Fully assembled Pi Cobbler.
This is a T-Cobbler. We've had T-Cobblers for a while. Plug into a breadboard and connect up to your Raspberry Pi, and it's a really easy way to, here, so you can see here, a really easy way to get your Raspberry Pi I/O pins onto a breadboard. Now it's fully assembled. For the same price, you can get a fully assembled T-Cobbler. No soldering required. Okay. This is a Shortening Pi SD adapter. It takes a little, you can see the microSD card kind of slotted in the side there. In this photo, you can see here, it's a little slit out a little bit. Yeah. And inside little contacts that bring it out to the main. So it's like a short version of a microSD SD card adapter, which makes it lovely for use with, say, a MacBook. If you have a MacBook Air or MacBook that has an SD card slot, this keeps it from sticking out.
Everyone really likes these for Pis.
But we like them for Raspberry Pis because otherwise the SD card sticks out a lot. If you have a Raspberry Pi, you're probably familiar with that. With this, it fits into any case without sticking out, which is really sweet. Less likely to crack off.
Goldie Blox with some more stuff.
This one is a dunk tank. This, I think, I'm trying to remember which skill this teaches. I think this skill teaches sort of like construction and rotating motion. So this has, I don't remember what it has. It has like, not gears and pulleys, but rods and connectors to make a sort of like a Rube Goldberg machine where you like toss something and something happens and then this dog falls into a tank of water. I guess that's the story. Just one of the other little skill sets for teaching young people how to do engineering skills. Yep. We have the Monk Makes sort of with Pi Leaf. It's like a, we actually already had something similar to this, which is the PCB version. This version is just a piece of paper, slips over the GPIO pins on your Raspberry Pi, and just makes it easier to wire because it's hard to keep track of which pins are which otherwise. This is a connector, 50-pin connector, surface mount. Not terribly useful on its own, but useful when paired with our 2.8-inch display. This is the display that we have in can you go too forward?
Yeah, sure.
2. This is this TFT display that we use in the Pi TFT and also our TFT Shield has a resistive touchscreen on top of it and a 50-pin flex connector, which you see. If you want to use this, when people are asking, hey, we want to use this screen for our own purposes because it's a lovely screen. So we have the screen now available separately, and we also have a connector, which might be handy since you have to solder it to a PCB. We have a breakout in the store that you can use with this if you'd like.
Okay. This is just another photo of the
it's a screen.
Okay, next up.
We have a UV index sensor. This is the SI1145. This is a UV index and light and IR sensor. It's kind of a general purpose light sensor in many ways. And it also has a calibrated method for calculating the UV index based on the light sensors. Took it outside and did a couple measurements, and yeah, it actually was able to calculate the UV index correctly according to the weather. So this could be really handy if you want to do projects that measure the outdoor UV index. Good to know if it's like, time to put on sunscreen or put on a hat. Also a good overall general purpose light sensor as well, and it's a fairly good price. It's kind of a nice, Silicon Labs makes great stuff, so I'm excited to get more Silicon Labs stuff in. The UV visible IR digital light sensor.
Okay, next up.
We have, the AD8495. This is an analog thermocouple, K-type thermocouple amplifier. We have a couple of thermocouple amplifiers in. They're temperature sensors for high temperature. This is an interesting chip in that it does analog voltage out. It's quite precise, but it has an analog voltage out. So this might be handy if you're using it in a feedback loop or something, or you want to connect a gauge to it and you just for some reason need analog output. We already have one wire and SPI, so now we have another method. So this is from Analog. They make lovely chips. This can handle, is there a photo of the back? Shoot, I don't remember the voltages. I think it handles like negative 200 to like 700, like negative 250 to 750 degrees Celsius, I think, is the limit for this sensor. And it can, what's actually really nice, it can run off of a wide range of voltages. You can run up to like 18 volts, which is, I don't know, maybe useful in some industrial automation situations.
Yeah. Okay.
We have a couple of accessories for the Teensy 3.0. This is the Octo WS2811. It's just, it sort of turns it into a fade candy a little bit. Fade candy is our NeoPixel driver. This is sort of the same thing, except it is just for the Teensy 3.1 in general, so you can use it, and it has a little level shifter. Makes it really great for use with NeoPixels, and it does the voltage conversion from 3 to 5 volts, since you need 5-volt logic to use with the NeoPixel strips with the Teensy 3.1. Okay. This is the audio chips. This is a, I don't remember the part number for this, but it's a DAC, and I think it's an I2S DAC. I can't remember the part number. It connects also to the Teensy and allows you to read wave files from microSD card socket. That's that silver thing, and output it to a headphone or line out.
Okay, a couple other photos.
Yeah, can I read what that part number? I can't remember what that part number is. I feel bad, but yeah, I don't know. For Teensy. More Teensy accessories. Okay. Can you move forward?
Yeah.
Okay.
I'm trying to do 8 things at once.
All right, we're almost done. We're almost done.
Yeah.
Okay, this is the MCP9808. This is a really cute little I2C temperature sensor. We actually did not have an I2C temperature sensor, and there was a hole in my heart. So I spec'd out what I thought was the best I2C temperature sensor we could get, and this one is quite nice. This has a typical accuracy of 0.25 degrees Celsius, which is really, really good. Most things do not get much better than half or 1 degree Celsius, but this actually has a typical accuracy of 0.25. It's extremely accurate. It has a precision of 0.0625. It's like a 12-bit DAC. It goes from negative 40 to positive 125 degrees C. The max accuracy is plus or minus 0.5 degrees, but you'll, for the most part, they don't guarantee 0.25, but if you look at the distribution of temperature accuracy, you'll see like 95% of the time it's within 0.25 degrees. And it runs from 3-volt or 5-volt logic, and there's 4 address pins, so you can put 3 address pins, so you can put 8 of them on a single I2C bus. So this is kind of like the best I2C temperature sensor I can get my hands on, and it's also very affordable.
Yeah. Okay, almost there. A couple more.
Okay, this is the Teflon coated version of the Malone Tech eTape sensors. This is a liquid level sensor, which if you were watching the show and tell, you'll see was used in a smart cocktail glass.
Yeah.
It says 12 inches long. You can put it, this is Teflon coated, so I guess it can be used, it's food safe. You can use it in situations where you're using chemicals. You want to measure how much chemical is in a tube or a tank. It's a pressure sensitive sensor, so it's how much pressure is being exerted on it. It knows, it can tell where, it's sensitive, so when the pressure of the liquid is pressing up against it, the resistance changes, so you can measure that resistance.
Yeah. And last up.
Oh, it's a 1K pot.
Okay.
Breadboard friendly, 1K potentiometer.
Okay, and that, Lady Ada, is new products.
New.
Good work. You did it.
Yay!